This is for Year 12 Specialists. It comes out of 8D, question 22, solids of revolution and their volume. So find the volume of the solid generated by the x-axis and the graph and these lines. Okay, so since this is tan of x, it will have an asymptote which is x equals pi on 2 and x equals minus pi on 2. And it's a positive tan, but it's been dilated, so we'll end up with a curve that looks like this. And pi on 4 would normally be 1, but now that's now going to be up at 2, and minus pi on 4 would normally be negative 1, but they'll be now down at negative 2. And we're looking for the region bound between this curve and the line x equals pi on 4 and x equals minus pi on 4. So looking for this and this. And because of the symmetry of the tan curve, they will be equal, and we're going around the x-axis. So that will be a volume which will be equal to 2 lots of pi y squared dx, going from 0 to pi on 4. And that will give me this revolving around the x-axis and then 2 of them. Now I'm looking over here because when I substitute this, I'm going to get volume equals 2 pi, the integral of tan 4 tan squared of x dx, because I need to square this. So y squared will be 4 tan squared of x. So I've got volume equals 8 pi integral of tan squared x dx. I can't integrate tan squared, so what I'd like to do is to integrate 0 to pi on 4 of sec squared x minus 1 dx, which will give me 8 pi tan of x minus x from 0 to pi on 4, which equals 8 pi tan of pi on 4 minus pi on 4 minus tan of 0 plus 0. Tan of 0 is 0, so we're at 8 pi times 1 minus pi on 4, which is 8 pi minus 4 goes into 8 twice, 2 pi squared cubic unit.